I just want to quickly introduce myself. I've been at Percona for about 6 years, almost 7, and I first joined as a MySQL consultant. I have had a bunch of different roles where I worked as a technical resource, as an architect, and then I moved to work with a number of our higher value clients, our larger clients. And the last couple of years, I moved to be a product manager. Monitoring has always been my passion. I loved installing the old cacti and Nagios back in the day. But I'm really proud to be in front of you all today talking about PMM and how it can make a difference, particularly around the PostgreSQL space. So while later on we'll be asking for some questions, or really you could put those questions at any time, be prepared for me not to be too heavily steeped in PostgreSQL, but I am quite familiar with databases in general. So I'll do my best to answer. But questions we don't get through today or that are maybe at a level that I can't handle, both Emily and I will take them offline and get answers from resources from within Percona. And what we do with those is we publish a blog post webinar to kind of show all the questions that came in and our responses. So it's public and made available to yourselves to look at anytime you want. Okay. So let's start quickly with what this product is before we get into the Postgres specific component. Percona for a number of years has been releasing software. All of our software, and it continues to this day, is free and open source. Free as in beer. Free as in a puppy. There's a little bit of work involved here. You don't get anything, legitimately free, because everything takes a little bit of care and feeding. But from Percona's perspective, we're investing resources to generate new software that does new features and adds value to your environment, and we don't receive monetary compensation from you unless you choose to be a customer of ours. And so I use that introduction because PMM extends that. What we're doing with PMM is we take a set of open source tools out there today, and we build a monitoring platform on top of it to give you visibility into your open source databases. We started with this product focused on MySQL. Then we added MongoDB support a couple years ago, and now we're working, since last year, we announced our own Percona services support for PostgreSQL. So here we are today talking about where PMM stands with support for that platform. Okay, and just so you're aware, there are other technologies that are also supported in here that are around this open source database, but they're not necessarily databases themselves. ProxySQL, for example, is a proxy system that load balances MySQL. It speaks the MySQL protocol, and we've got quite a lot of visibility into ProxySQL. We also have the ability to monitor both RDS MySQL and Aurora MySQL, and also remote PostgreSQL instances. So that means both RDS PostgreSQL or any of the other popular cloud platforms. If you can connect to your PostgreSQL instance using the network to a port, then you can use PMM against it. It doesn't have to be something that you're necessarily able to get host level access on. These databases as a service, you never have host level. So PMM covers both those use cases. Something also that's unique about PMM that you don't necessarily see every day, this isn't a SaaS. This is a product, or piece of software, or set of software, I suppose, that you install locally in your own environment, and there's no communication outside of your network to Percona to say, here is the queries that are running, or here is the metric series, and then you fetch it from our platform. Everything that happens here, the client and the server side, are all installed on your hardware and your equipment. And why we like that is that it means that the security and the confidentiality of your queries and other pieces of data are within your sphere of control. There's no chance for exposure due to Percona. It's due to your network authentication layers and other things like that. And finally, I just want to include that it's also uses security while it's communicating across the network. We have SSL between client and server, and also SSL between the browser and the PMM server instance. So this is based on a client-server architecture. What that means is that on the client side, if you have host level access, we have an RPM or a deb package, or if you want to, you can build it yourself from our sources. And what it enables you to do is install a local client called PMM client, and that exposes 2 core pieces of functionality. One of them is this concept of exporters, which I'll show a little bit later what those actually are. But basically an exporter is a way that speaks the PostgreSQL protocol, can log into PostgreSQL, it can fetch metrics and expose them to be collected later. And it also installs what is called a node exporter. A node exporter enables PMM to collect host level metrics. So again, if you have a compute platform or an on-premise installation of PostgreSQL and you install these clients locally, that means we can tell you very clearly how busy are the disks, what are the CPUs doing, what's the network throughput, et cetera. And that's all due to node exporter being installed locally. And then on the server side, there's a number of different ways that the server can be installed. Arguably the most popular one we see from our own metrics that we collect, looking at downloads and things like that, is there's 3 of them, but the most popular is Docker. Docker container, it's a single Docker container that contains multiple binaries running. And those different binaries, as I mentioned earlier, are these other open source projects, such as Prometheus, which collects metrics and stores them locally. It's in the top 10 most popular starred projects on GitHub. And the other one is for visualization. We'll be spending a lot of time looking at this because this is the main interface in the PMM server. And we use Grafana. Grafana also is probably in the top 5, I think. It's hyper popular these days. I'm not sure I'll even call this right. It's a visualization tool. It's a graphing engine which reads data from Prometheus and displays it. And where Percona makes a difference with PMM server itself is that we take all of these other open source projects, and if you're familiar with them, you might already have them running in your environment, and you're probably at least tangentially aware of the care and feeding that needs to go into it. And so what's unique about PMM here is that we give you an already bundled Grafana working with Prometheus, with Console, with Service Discovery, with a whole host of other things, with our working dashboards for PostgreSQL. So the value add to using Percona's variation of it versus rolling it yourself is you can count on Percona to do a release approximately once per month. So there's always new features being introduced, either driven by Percona, because if it's a new dashboard or some other new functionality we create, you get to take advantage of through a new release. Or you also get the advantage of, for example, Prometheus releasing a new version. We're very aggressive about pulling those into our releases. So whatever introductions the community has received, you don't need to go through that upgrade. It will happen as part of your PMM upgrade. And you and us, Percona, we all receive the benefits of these other projects that we stand on the shoulders of and enhance the value of PMM overall. So there's a lot of advantages to using our Docker distribution. It's super easy to do upgrades with, whether you do those in place or whether you do them through just rotating out the container. It's usually only a few seconds downtime to do upgrades with this. So keeping up with our latest releases, usually every month, is not usually much of an onerous burden for you. Whereas if you're rolling it yourself, you might have a whole bunch of other dependencies involved with upgrading Prometheus and other sorts of testing you need to do. And then the other two distribution methods, just so I call them out, our second most popular is our AWS Marketplace presence that we have. And what that basically does is it copies PMM server onto an AMI for you. So therefore now you have an EC2 compute platform that you can use to keep all of your network traffic localized, which I guess it will save you a bit of money because now you're not paying data in and out of AWS. And you can scale that to whatever size you want, attach EBS volumes, what have you, as you need to expand disk, etc. And then the last one is if you're running a technology such as Red Hat virtualization or Microsoft or VMware, we release a third variation from using the OVF, the Open Virtualization Format Container Package, I suppose it's called. It ends in .ova, but the name is OVF. You could use that with VirtualBox if you want to do some local testing, or again, like I said, in a much larger virtualized environment, you can use this to clone PMM server and stand it up on VMware or one of these most popular virtualization platforms. So I screamed through that because the bulk of this call is about how PostgreSQL works with PMM rather than how do you get PMM up and running. We have other webinars that can help you get started on deploying PMM and some of those best practices. So let's move into some of the features around PostgreSQL. When we look at our support for RDS and Aurora, you've got the ability to connect to what we call a remote instance. That remote instance happens to be within AWS, is where we began much of our work. We have a relationship with them, and they kind of helped us move things forward with understanding how their platform works. And it was basically the first place we focused our attention. But these days, we can also connect into an Azure or Google or any of the other top tier hosting providers where they expose PostgreSQL on the network. If it has a port, we can connect to it. And so what's involved here? If you're using AWS, we'll spend our time there first. You would put in your access key ID and your secret key. And the only reason we ask for that is then we do a query against the API for, I'm just gonna call it the AWS API because I forget the specific name. But what it does, it just does discovery. It says, give us back a list of all of the database as a service instances that are running there. And in this case, you can see that we've got both MySQL and some Postgres coming back in the result set. And so what you do is you select your Postgres instance and you would put in the username password for it, and then you'd have it added as a remote instance here. In this case, I'm actually showing Aurora-based ones for MySQL, so I apologize that it's not specific to PostgreSQL, but it works the same, username and password. So it's very, very click and point. You can add instances in a matter of minutes if you're hosted with Amazon. So now to the more generic use case. If you have a remote PostgreSQL instance, we have the ability to supply in host name, port, username, and password all in one screen. And this way you'll be doing it one at a time. You'll fill in those fields, you'll click add instance, and your and the host will be added. Give it a minute or two to collect some data, so there's things in your graphs, and then you'll be able to look at those metric series. And I'm going to highlight one more way that you can add these using the command line. How would we do this? This works either whether it's local or whether it's remote. Okay, so as I mentioned earlier, you'd install this PMM client. In this case, I'm using the RPM version because I'm using Yum. You need to do two operations when you're using PostgreSQL, or really any service. The first one, after you install the client package, is to use PMM admin and the config option. And config is basically saying to the client, where is my PMM server out there? And that's signified by the -- server and the IP address. And if you have authentication attached to that server, you'd pass it at this time. If you do things with PMM admin config help, it's got a very rich help displayed to output to you what the valid options are. But in this case, it's very simple. I didn't have any security configured on this. It was basically an unauthenticated PMM server in a secure environment. So I just said, here I am. Here's my server, my local IP address, which it will auto-discover, and just tell it where the remote PMM server is. It registers itself and says, okay. Now I know that at least over there at this where PMM client got installed, that there is a node that will eventually start talking to me. The next step is to advertise to the PMM server. So this is step 2. My second command is to add a service. And the other valid services other than PostgreSQL would be MySQL, ProxySQL, Linux metrics, and a whole host of other ways that you can just basically slim down what exactly you want to export or expose from your instance. In this case, though, for this webinar, it's about PostgreSQL. And when you do this little shortcut of add PostgreSQL, what it's going to do is it's going to log in locally. It's going to confirm it can authenticate to it. It's going to create a user so it runs as a separate user. And therefore, you can then segregate access controls. You can say access to this database or not to that other database, et cetera. You have the ability to basically limit where PMM is going to be able to gather data and where it's denied gathering data. And when you use this shortcut format of just add PostgreSQL, it enables two types of metrics collection. One is this Linux metrics, which is based on this node exporter concept I talked about. Linux metrics means what kind of host level activity am I going to collect it or am I not? And we at Percona, as open source database experts, value very much having awareness of the host level wherever possible. That enables us to say, okay, your database server might be busy. That's great. It might be because of queries or it might not. There might be some other noisy neighbor. There might be some other contention on that host. Maybe you don't have enough cores. Having the ability to use node exporter and have this Linux metrics enabled means that our dashboards are filled in and we can show you relevant data about the behavior of the host and whether that's impacting your service of PostgreSQL or not. And the last one's relatively self-explanatory. PostgreSQL metrics means we enable what's called the PostgreSQL exporter, which means it has the awareness to know how to log into PostgreSQL, how to fetch metrics from it, and then expose it to be collected by PMM server. The second one is really the meat and potatoes of the whole point of enabling PostgreSQL here. So when we get into the dashboards, like I said, we really just opened up support for PostgreSQL by Percona as a technology from us just last year. So we're still kind of dipping our toes into the water right now. I've got for display only one dashboard today, but I just had a call this morning with my PostgreSQL team, and we've got 3 more dashboards already in the works. So watch for that to be in our May release, and I'll get into a little bit of our future forward plans that we're talking about, plans that we're planning for upcoming releases towards the end of this call. But today we have an overview dashboard. And we started with this because we like our overviews because it's just the quick hit over what's happening within the database server. So the high level top row is some relatively static data. Max connections might change after restarts and things like that. But by and large, these are kind of the how have I configured the server without checking a config file or logging into the server? What's interesting about it? What size are my shared buffers, et cetera? We move down a little bit to some of our connections related and our tuples. So we're looking at how many connections, what states are they in, and which databases are they connected to internally. Okay, I apologize for the active connections having such a high number for maximum. It makes the other lines not so clear in terms of connections per database. But the point is your environment, you would have obviously likely much more fluctuating depending on follow the sun model of client activity connected to your application or your website. In my case, we're running synthetic workloads, so it's not a very changing environment. And then finally, there's some information here around our tuple activity. This dashboard actually spans about 3 or 4 screens, but I'm only showing the top quarter of the screen right now. I'll lay a plug right now for our PMM demo environment, and there's an environment there which is public, pmmdemo.percona.com, And on that platform, it means that you can connect and look at MySQL, MongoDB, and also PostgreSQL instances as they're running with these synthetic workloads. And so you can then view it yourself and navigate through and click and inspect a little more deeply each of these graph elements to see if it would make sense in your environment, if it's something you'd benefit from. I'm going to move to another concept within PMM that I'd like to highlight. I get asked this a lot on calls. Does PMM support alerting? And what does it have to do with PostgreSQL? Well, the good news is we are able to offer alerting because we use Grafana, and Grafana supports alerting. If you're familiar with Prometheus, it also has alerting through its alert manager, and we're looking to kind of build a more robust alerting platform using that technology, but we're going to probably tackle that in Q2 or Q3 this year. It's not something that we've got ready to deploy yet. But what works today is Grafana alerting. And what's kind of neat about this is I'm showing it as a MySQL example, but it applies to any technology that you're running because Grafana doesn't care about the database. It just cares about, is there a metric series and what's going on with it. So with Grafana alerting, what you do is you identify a server and a metric series. In the case of maybe queries per second, you might want to be alerted when queries drop below a certain threshold. I happen to care about that because for my PMM demo environment, I'm responsible for it. If it drops below 100, you can see this little heart with 100 here. If it drops below it, it breaks the heart and everybody's sad and I get an alert. And what's kind of neat about that is that with multiple channels, we happen to only use one at Percona. I use a Slack alert, and it just uses basically a webhook, and I get a ping and a special channel for notification events. But it supports PagerDuty, VictorOps, a whole host, maybe a dozen or so different channels that you can receive alerts, SMS, email, etc. So Grafana is relatively robust if you have a medium to small deployment. If you have a large deployment of maybe 100 servers or plus, that can get a little bit difficult to manage using Grafana alerting. But 100 or less, you can pretty much handle it because your hosts are probably not changing too frequently, and therefore you can stay on top of host names and treat them more as pets rather than cattle. Okay, so just to highlight how these things get pulled together, I'll go through this relatively quickly. With Prometheus or with any platform you're trying to monitor against, you would specify the metric series that you care about, which is on the left-hand side. I'm saying I wanted to find a new graph that is plotting this metric series of queries per second, for example, using a named host. And then I go over to the alerting tab and I say, for this query line, which is query line A, I want to get an average over 5 minutes. And if that value drops below 100 in my example, I want you to send me an alert. I want you to do something. And that's it. You just walk away from it. So you can basically clone these dashboards, update the instance names, and walk away. Now your whole PostgreSQL fleet is now being monitored for whatever the existing query threshold. It might be something around, number of concurrent threads or connections or something else like that. But the point is that once you define it once, you can easily copy these and have multiple alerts set up, within a handful of minutes. So I mentioned some of these channels. I won't spend too much time on it here, but I dig at them all. Email, Slack, PagerDuty, Alert Manager. You can actually send these alerts from Grafana to the Prometheus Alert Manager and then have it help you with silencing multiple alerts as they come in, because maybe with the network partitions, you don't want to get bombarded with, I can't also reach PostgreSQL. So Alert Manager can help you with that, but it's a much more significant product in terms of alerting than just what Grafana can do. Okay, so we're towards the end here. What else are we going to do around PostgreSQL? Well, since it's new to Percona, there's a couple components that are missing right out of the gates. One is we have a relatively strong query analytics component already in place for MySQL and MongoDB. And what is that? Well, what we're going to do, or what it does today, is it shows you which queries are spending the most amount of time in the database server. And where we'll get that data going forward is we'll use pgstat statements and be able to collect all of the runtime information about queries on a regular basis, so that we can aggregate that and say, for this query pattern, here's how many times we saw it, and here's how much time the server itself spent answering that question. We boil it up into a screen, a pretty GUI, and it says to you, okay, these are the queries that took the most amount of time. Here's the ones that you want to spend the most amount of time troubleshooting. Because if you could take a query that's doing 50% of the workload for the server and reduce that, that offers you considerable advantages. It might mean that you can delay upgrading the size of the server, you get capacity back, you can deploy a new feature sooner because suddenly you have new capacity discovered. Or maybe in a hosted environment, you might be able to reduce the size of the instance and save a bit of money. And generally managers love to hear that kind of conversation when you can optimize queries that way. So we're gonna focus on query analytics as probably one of our first big pieces of new technology. But let me slip in, I name dropped it earlier, we're gonna have some new dashboards come out in our new release in May. And those dashboards are going to be focused on PostgreSQL's view of replication, And we're going to do a couple around different types of ways of looking at the tuple activity. So watch for those. I'm going to probably write a blog post in the next few weeks, kind of pre-announcing it, showing some screenshots for it. But we've got some dashboards that'll be new, that'll make it in the release. Then we'll work on query analytics as we get into Q3. And we also want to focus on a little bit of how vacuum is working within PostgreSQL. We want to show some metrics on how efficient it's been, how frequently it runs, etc. The whole premise of this tool is to provide visibility. It's not necessarily to make changes in terms of your Postgres deployment, but it is designed to say, here's what's occurring. And if you're a Percona customer, you can use this technology to share that data with Percona and say, what do you make of this, Percona support? What changes do I need to make? Should I be concerned? Or can you just help me understand the behavior and tell me that everything's fine and I can go back to bed right now because there's not actually a problem ongoing. So again, just to restate, PMM is all about visibility of your open source databases, and we have huge ambitions through this year to make significant improvements around PostgreSQL. I will mention again, pmmdemo.percona.com is the free resource for you to use. It's available on the internet. And you can also download right from that page. You're able to see our documentation links and follow through some of the installation paths for getting PMM deployed at your environment. If you want to write this down, percona.com/PMM takes you to our landing page, which has some videos to help you get up and running. It's got some other introductory talks that I've done on this topic, and is basically designed as a one-stop shop to help you understand what's available and how to get moving forward with this platform. And so at this point, I wanted to pass it back over to Emily and open it up for any questions.
Great, thank you so much for that, Michael. At this time, go ahead and enter any questions that you may have in the questions panel down below. Questions that we couldn't answer will be answered in a follow-up blog post. So, our first question is, do you need a PMM server in each data center? And then a next question to that is do you need a dedicated pinned resources if run on a virtual machine?
Very good questions. Let's focus on the first one. Depends on the latency between your data centers. The premise of PMM is to be relatively aggressive in its data collection. And by default, we are asking for new metrics from, in this case, a PostgreSQL instance every second. So that means there is a network connection from the PMM server to the exporter. Then there's some compute time to gather those metrics. And then there's the TTL to come back to the PMM server. All of that needs to happen within the scrape interval of 1 second. So if we're talking about, US East to US West, speed of light, I think that's about 66 milliseconds across the country. That's probably achievable. You could have one PMM server in either East or West and live with that. But if we're talking about, you're hosted in Ireland and maybe Singapore, that might lead you to a different type of a deployment. You might need to then co-locate those instances is one option, which makes it a bit more complex. Now you've got two different URLs to go fetch data. It's not a unified view anymore. The other approach is to instead don't collect this as frequently. It's a bit of a trade-off because collecting less frequently means you can tolerate longer round trip times, etc. But when it comes time to troubleshoot a very, I saw it now and it's gone now, kind of a transient problem, it makes it a little more difficult to troubleshoot if you're only collecting every 5 seconds or 15 seconds. So be cognizant of how much detail do you actually need. Sometimes you do need to scrape more frequently, and then there's a trade-off with that network round trip time. And I'm sorry, Emily, I lost track of what was the second question?
Do you need a dedicated pinned resources if running on a virtual machine?
Good question. It depends. It depends on how many instances you're tracking. And really what you care about in terms of response time to page loads from PMM server. What I mean by that is we have done some testing and we've been able to show that with a given PMM server with fairly decent resources, I'm talking maybe 64 gigs of RAM and 16 cores, you could add maybe 1,000 PostgreSQL instances and still collecting at the 1 second resolution level. So if you've got less than 1,000, you can get away with one virtual machine deployed to do this. In terms of whether you need to pin those resources, I would leave that as an operation to yourself to decide if the response time, if there's a noisy neighbor stealing resources that happens too frequently, then yes, you need to consider pinning it. But I could conceivably see a scenario where you don't pin it and deal with an infrequent noisy neighbor, and maybe once in a while you have some gaps in your graphs. But if you can live with that and run it on effectively cheaper hardware, by all means go for it and share your experiences with Percona, either as a customer or through our forums. I'd love to hear some feedback on how well that worked out for you.
Thank you. See, our next question is what permissions does the database user require to monitor Postgres?
That question is specifically answered in our documentation. We show the creation of the user step that needs to occur. I'd actually have to look it up, to be honest with you, what those specific requirements are. I do know that you need to you need to be very explicit about which database names, you're giving access to. And when I did my configuration of it, I was using, I would remove the ident lookup and do things as I believe, a socket connection locally. But off the top of my head, I don't remember what the actual permissions were. That's something that I will make sure that I answer in the follow-up blog post.
Thank you. Let's see. Our next question is, can you integrate PMM with the Nagios monitoring platform to allow Nagios to act as your global alerting mechanism?
I haven't had that question before. A lot of times PMM is replacing an existing monitoring platform. I have used Nagios quite a bit, but I'm not familiar with how it integrates with other monitoring platforms. I've only ever been all in or not at all using it. What I'd like to do, rather than give an answer that doesn't go anywhere, let me do some investigation on it and see where the ability for Nagios to connect to another alerting platform exists, and see if there's a play there for PMM to be part of that.
Thank you. Let's see, next question is, how could you work with Amazon RDS instances? How does PMM work with Amazon RDS instances? I can't talk today, I apologize.
That's okay. There's two ways you could, well, I guess there's three ways you could get it to work. The first and simplest is that we've already built in effectively native integration with RDS. I should say air quote native. What we do for MySQL is similar to Postgres. You have this access key. Go back to the slide here. And the key enables us to list which instances are deployed in your account. So let's say you've got 3 PostgreSQL services. They'll display here in the bottom screen, and you'll click on them and choose enabled, and you'll add the credentials, the username, password, and away you go. Now they start appearing in your dashboards. This is the easiest way to do it, is to use the AWS credential screen. What is missing from our PostgreSQL support that we do have for MySQL is that we have a dedicated dashboard that's populated based on the CloudWatch API. And why that's interesting is, again, this is a hosted platform, so you don't have access to the OS level metrics. Well, not the dirty secret, the way that Amazon does this, RDS does this, is they deploy, in our case, PostgreSQL on an EC2 instance that you just don't have access to, but you know there's still host level metrics. CloudWatch gives that to you. So one of the things we're going to work on as part of our rounding out the Postgres offering is to say, hey, connect to the API for PostgreSQL, for CloudWatch, and fetch those PostgreSQL CloudWatch metrics and display them on a graph so that you have the OS level activity. So that's probably number one, use this AWS screen. The other one is just treat it like it's a remote instance, and therefore it's ignorant of whether it's in Google's or Amazon's or anybody's platform. It's just a PostgreSQL server out there that's remote to me, that I have a username password to, and I know its IP address or its host name, and I connect to it. That is this one here. This is probably the second simplest one. It's got a couple more fields to fill in. And then the third one is to do a command line one. I don't show it here in my full string, but what you could do with PMM admin add PostgreSQL is add some more parameters. One of those would be -- server address, I believe, and you give it the host name or IP address. And therefore now we're going to connect remotely to it and run this agent locally, but connect remotely to the Postgres instance. But what you lose here, it's similar to the two prior ones. You don't then get the Linux metrics being installed, which means you don't have any visibility of the host level activity. But that's basically how you could treat 3 different ways of treating a remote instance, whether it's in AWS or not.
Thank you. Our next question is, minimum memory requirements is 2 gigs for one monitored database node per your documentation. What is the minimum CPU requirements?
We're really cagey about that, aren't we? We say 2 gigs because we don't want people running it on, like, I don't know, some T2 micro and expecting great performance. We do have reports of people being able to run it on the ½ gig instances, but really if you're monitoring more than a couple boxes, it's just going to crater. Where the resources come in is it's Prometheus by and large. It's got a unique workload going on here. Prometheus is not a traditional database in the sense of, if we look at our Postgres or any of our OLTP databases, most of the time they are read-heavy workloads with infrequent writes. There might be some batch writes at midnight for new orders and things like that. But by and large, we're reading and displaying data for a website or some other application. Where it's the reverse for Prometheus. Prometheus is a virtually like 99% write-heavy workload, but the cool thing about it, it's very stable. Once you've got to some number of nodes added and you're not modifying or removing nodes, the write workload is very, very flatline, meaning it's going to be doing 10,000 ops per second or some number, but it's not an up or down number. It's a regular schedule that data is being fetched and needing to be committed to disk. And there's a ton of optimizations that the Prometheus developers have made to kind of merge and key-s data and all these other kind of things to kind of minimize the impact on the server, but it's a relatively flat workload. And so where the magic comes in is that this is right from the get-go, Prometheus was developed using Go, and which means it's multi-threaded by design and by natively. And so throwing more cores at a Go process in general is a good piece of advice, and specifically about PMM server, because it's using Prometheus, is a very specific piece of advice. So all of that being said, what is a good number? I would say I wouldn't deploy anything less than a 2-core if I'm monitoring maybe 5 servers, and I'd be probably rolling into the 4 or 8 cores if it's not too prohibitive for anything more than maybe 10 instances. Because what I'm looking for is we've got a number of dashboards that help show the health of Prometheus itself. And again, maybe I'll include that in the blog post. But the point is we have a graph that will show you how healthy Prometheus is, and that graph, having kind of grown up myself with this whole product and learning Prometheus on the fly, that's a hyper important graph of how many cores is Prometheus using versus how many cores is available. And we've got some very specific thresholds on that chart that I'll include to help you understand. Deploy it on something small, add a few instances, let it kind of settle out over a few hours, and just take a look at it. If it's within about 75% of usage, you probably want to add some more cores to it. But using any of these hosted platforms, or if you're doing virtualization yourself, it's relatively straightforward to add more cores. So save some money, start small, and then grow it as needed.
Thank you. Let's see. Our next question is port 5432 the only port that must be opened in the firewall between the PMM server and the database server?
Let me break that down a little bit. The path actually goes, how do I start this? Let's start at the server side. So you've got this remote server running somewhere in your environment. And to connect to that server, its ports, well, you can choose to change this, but you're going to connect either over 80 or 443 because you're interacting with it you're using your browser. Now, that server, because of Prometheus, it does things a little differently than maybe some other monitoring technologies you've used before. Prometheus is based on a pull model. And what that means is there's a clock that's running in Prometheus, and it has awareness of all these other endpoints out there, or targets it calls them. And a target to it is very straightforward. What's the IP address and the port it needs to connect to? And what it's going to talk to are other exporters. And in this case, we're talking about the Postgres exporter and the node exporter. There's 2 exporters there. So IP address 1234 at port 42004, I believe is the PostgreSQL exporter port, and 1234:42000 is where node exporter lives. So if we take an example of, I have my PMM server running on one server, and I have my PostgreSQL server running elsewhere at 2345 as my IP address. On 2345, I need to share 2 ports. I need to open them up. I need to have port 42000 and 42004 open, because the agent, or the exporter will be running locally, and the exporter can still connect to localhost or to whatever local port that's available. Now, you might need to make some firewall rules there to let 5432 be available, but that's more of a local control. So the more significant one is, how does the PMM server connect to the exporter? Those are the rules that really matter for us to get right. Otherwise, you'll have the exporter connecting healthily to the PMM server, to the PostgreSQL server, and metrics are being collected. You can see them through connections being driven inside of Postgres, but you're not seeing any of your graphs fill in. Everything looks empty still, and that's because probably you haven't opened up a port in the 42,000 range. So it's kind of a deployment specific question, but the common way that I see things get done are people do this local PMM client installed locally, and then they need to pay attention to the 42,000 series ports being opened from the PMM server to reach in and do that data collection.
Thank you. Yeah, it looks like it's port 42,005 according to the doc. So
I'm sorry, you're right. 40,004 I think is Mongo or something else, or ProxySQL, something like that. Thank
yeah,
you.
it's close enough. So let's see, our next question is what is the largest number of servers or databases you can monitor or have seen monitored in PMM?
I gotta do a shout out to our CEO, Peter Zaitsev, who I guess had a quiet weekend and decided to play with Linode, and launched 1,000 instances and was able to show that, I have to check his notes again, but I think it wasn't much more than a 16 core, 64 gig PMM server. And he monitored 1,000 instances at a 1 second granularity. You could probably go bigger than that. I'm not sure how much more, but it's somewhere floating around 1,000. And then if you start slimming down the resources, of course, it's going to be some sort of a drop from that. But I'd start with about 1,000 as a safe number.
Sounds like a fun weekend project. Let's see, our next question is do you have the ability to configure HA for PMM?
I love that question. I wish I had a better answer here. Depends on what we need for HA. What we can offer right now is the ability to take a backup of your PMM data and say, okay, if this instance fails, if I lost everything, if the EBS volume went away, for example, I've snapshotted it, I've got the data elsewhere and I can restore it or basically clone it again and make it instantly available elsewhere. And then what you do if you're using a Docker installation is you just connect to this container and you're back up and running within probably minutes, depending how long you can click in the interface and react to an outage condition. So we have the ability to take a backup and do some cloning and get you back up and running. What we don't offer yet is the ability to deploy more than one PMM server instance that is aware of each other and is able to say, I'm monitoring each pair, and if one fails, things automatically get routed and things like that. That isn't yet supported. It's something that we've got on our roadmap, but we haven't really seen a clear path forward on what we can do here. So this is a bit of not so much of a pleading call, but a request for feedback. If anybody has done this with Prometheus and Grafana, I'd love to hear maybe his comments on the blog post we'll push, or reach me directly, michael.coburn@percona.com. I'm looking for active participants to help me, not just with here, have you thought of this, but also, yeah, we've deployed this and we've seen this work, or we've tried this other path and it didn't work for us. Each of these technologies, Prometheus, Grafana, Console, they all have their own concept of how they can do HA. So theoretically that the premise is there, but how do we make it work for PMM? I'm still kind of trying to understand how strong that HA level needs to be. And if anybody's done this before, I mean, again, I'd love to hear some of that feedback.
Great answer. All right, well, we look like we're actually getting close to the end of our session today. Thank you so much, everybody, for attending today. I'll make sure to pass all of those questions on over to Michael. Thank you so much, Michael, for presenting today. Learned a lot, and it was a great session.
Well, thank you very much for the time.